All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the winter 2022 semester at George Brown. It's week 13, part 2 of our broadcast, which is crazy. This is a real challenging one for sure. And the reason why it's so challenging is because there's a lot to do, and as always, very little time, to get things done with the stuff that we have to do for today. Okay, so that's what's happening. Let's move on to what we're doing today. So this week we talked about utility theory a little bit in the lecture part. And we talked also about action execution and how to do actions. Things that are due. Lab 7, parts 1, 2, and 3 are now due Sunday officially at midnight. The lab report will be up later on today. That is the final lab report for all those 3 parts. Each part is worth 4% of your final grade. So it's definitely something that will affect your final grade if you don't do this one, as it's worth 12% altogether individually. So make sure this is like as big almost as a assignment 4, right? So for individuals. So it's really huge. Make sure you get it done. And again, a lot of these labs this semester has taken the place of mid-semester and final exams. That's why labs are super important this semester compared to others. Assignment 4, again, is due week 14. That's next Sunday at midnight. And it's based on all the lab parts that we've given you from lab in the second half, from lab 6 on, if I'm not wrong, even earlier than that. And also just to note that submitting lab 7 as assignment 4 will not suffice. You will not get any marks for that. It has to be the completed lab or assignment 4 that we've asked you for, which is your own assets. And there are parts that are missing from lab 7 because, of course, we don't give you all of the assignment. You have to do some of it yourself. So that is the part that you need to do. All right, so that's lab 7 and assignment 4 and when it's due. So let's get this lab 7 stuff done. This is the last part of it, and let's get moving on this. So yeah, so let's follow in Alex's structure to talk about what he says. So there's a lot of change files, and one of the things that he's talking about is setup. And setting up lab 7 part 3, we're going to use lab 7 part 2 to start. So let's get that going. And I'm going to go into section 400. There's lab 7 part 2, and we're going to copy paste that and make it part 3. Right? And that's the first piece. Nice. Let's rename this to Lab 7 Part 3. And I did it differently in the first section. And I think what's probably best to do this time around is add in all the files. What I've done is, what it's telling us to do is grab files from our labs folder. And if you notice, Alex has given us a bunch of files: the torpedo.og file, assets.sprites, the src.zip file with a lot of changes, and an updated or action node, which we're going to overwrite in the src folder. So those are all the requirements. And he's talked about where all of them go. Let's put that into place first before we start. I think this is important. So what I've done is I've made a very simple sandbox for lab 7C. This is it right here. And what I'm going to do is I'm going to copy paste into lab 7.3. So inside of, let's start with the assets. Those are easy. Assets audio. I'm going to grab the torpedo.og and put it inside there. So boom, boom, there it is. I'm also going to grab the assets sprites folder. So again, sprites, you can see that there is Atlas and all the stuff. This sprites folder is going to include the Torpedo Sprite, all right, which we're going to look at. The Torpedo Sprite actually looks like, not that yet, like this, which is basically a 64 pixel by 64 pixel object, right? That's what it is. And it has several states, 1, 2, 3, 4, 5, 6, 7, 8 frames of animation for this little kind of projectile. That's what's happening here. This is what we're going to have you do. So test out a little projectile. and that is the torpedo and the torpedo animation with its own data file. So there's two parts to an animation. There's the actual texture sheet, the sprite sheet itself, which is also called the texture atlas, as well as the torpedo data file. The data file basically tells us where the texture is located on the, where each of the frames is located on the texture. So for example, the first frame is located at 1,1. That's where it gets, it starts, and it's 64 by 64 in width, like all of them. Okay, so that's what the data sheet does for us. And that got added in there too. Next, let's go into the SRC folder. The SRC folder has many changes, but you know, what we want to do is we want to grab all this. So Control A to add all this stuff. And again, I'm going to go back into my files for this is lab 7.3. I'm going to go up into the SRC folder, and then we're going to paste those changes. So paste. And it says replace 13 files. Let's replace them. So updates. Alex has given us updates to a bunch of files, including the action node. And I think what I did was I copied it in there, but just to be safe, I'm going to grab that. Yeah, I think I did that. I think I copied the action node already in there, and I put it in here. So that's what I did, and I can tell because the action node is today, and the action, all the other stuff is yesterday, the 6th. All right, so that's what's happened. So that I've just copied everything into there as we've been requested from this part. So we started off, and it said, hey, use this as a start, and let's do our first commit. What I like to do always is make sure that there's no errors before we do our first commit. Let's get that done now. So let's say launch our project. So let's go to here, and we're going to go to lab 7.3 and double click on our template, and let's see what happens. And whenever we do one of these, what we want to do is we want to make sure we close all these off. I'm just going to close all tabs. And we want to check for build errors before we put it up. So if there's any kind of build errors, we want to fix them, and then we go from there. So let's go build, and we're going to build solution. So this is going to build our solution, not actually running it, just building it, so we can see if there's any errors. And then we'll run it to see where we're at. All right. So if we have any errors, they'll come up. If there's no errors, it'll say we built everything successfully. Okay. Now, we shouldn't have any errors because we didn't add those new files in. We haven't done that yet. All I want to do is build and make sure that anything that got changed doesn't cause problems for anything else that's in here right now. And then we'll start adding the files and put this up to GitHub. Okay. When I say add the files, even though the source SRC folder has been changed, remember that we have to, there's one. So set line of sight condition that says in the play scene, there is a new, we're going to move that somewhere else. We're going to kind of comment this part out. Okay. So let's comment this one out. That was the old one, and that was the only error that we got, which means so far, if I run it, then we should have the old project from last day without any line of sight checking. And note, what's the other error? So it says unresolved external public player detected condition and in the close combat enemy. All right, so close combat enemy object, it says the player detected condition doesn't exist, right? Because it says we don't have our player detected condition. Well, guess what? We haven't added that back in. So let's add those in now. That's the new stuff. So let's start with actions. So far we have the attack action, and we have the move to line of sight action and everything else. We have other actions we're going to add in. Let's go to right click on actions and add existing item. And we're going to look inside of the SRC folder now. And we're going to look through the first set of actions. So we have the attack action, nice. But there's a new action called the flee action. Let's add that in now. So flee action, let's add that in. All right. Also after that, we also have a move to cover action that's not included. So let's just scroll down to that and just control click those, move to cover action. So again, we have flee action and move to cover action that we're adding in. We're adding them as existing items. Move to line of sight action is already here. Move to player action, that's already here. Move to range action, well, that is already here. And we have a patrol action, and we also have a wait behind cover action, which is new. So wait behind cover action, which is down here. So now we've added all of them. If I click add, then we should have a set of actions that look like this. Attack action, flee action, move to cover action, move to line of sight action, move to player action, move to range action, move up the patrol action, as well as wait behind cover action. So those are the new actions. Nice. Let's add in any new agents. No, we don't have any of those. We can kind of close this filter. Conditions. We have new conditions, and we're going to add them in now too. Let's go to add existing item, and let's look at the conditions that are in there as well. Okay, so starting off, we have our close combat condition. The next one is our a new one, which is the enemy health condition. Let's scroll down to that. Enemy health condition is there. There's also the enemy hit condition. Let's do that. Enemy hit condition. Those are other ones. Those are new ones. Enemy health and enemy hit. There's also line of sight condition, which we already have. We also have a player detected condition, which is new. Let's scroll down to that one. So player detected condition. Player detected condition is control clicking to make sure that's good. We have a radius condition, which I don't think we're going to use anymore, and our ranged combat condition, which has already been made. And let's just add those in. So now for our conditions, we have a close combat condition, enemy health condition, enemy hit condition, line of sight condition, player detected condition, radius condition, which you're probably not going to use, and then the ranged combat condition. So those are all the conditions that we had from last time, or the new ones. Okay. Yes, these are good. These are excellent. And we also have some additional files. We have the torpedo. We know that one, as well as, and that's going to be inside of our game objects. Let's add the torpedo in there. So, but we also have in the torpedo a couple of new things. One of them is we also have the torpedo animation states, and that is an enum. So let's go to the enum first, add that in. So, and the enum, go add existing item, and we're going to put in torpedo. If you scroll down, and it's torpedo animation state.h. That's a new one. So we'll add that in. There we go. Followed by the game object, which is the torpedo. So right click and add a new existing item. And again, we're going to scroll all the way to the bottom here, and we're going to go to torpedo.cpp and torpedo.h. Let's add those in. Now, the thing with torpedo is it's a projectile style, and if you look at torpedo.cpp, pretty sure that we don't have projectile as a type. That is the game object type, which is inside of our enum, right? So if I go to game object type, we can see that there is a bunch of stuff, but there is no, from a torpedo perspective, we're missing the projectile type. I'm just going to copy that and go into our game object type and just plop it in right here. Right, so there's our projectile. Now let's make sure there's another comma. All right, and save that. So that is, I think, most of the things we're supposed to add in for today. Okay, so that's the stuff that we have. Again, we should build our project and make sure that we've got mostly everything. And if we don't, we can go back and correct it and find the problem. All right. Again, what I want to do is I want to get a build, and I want to build succeeded. I don't want to move on with anything else, anything new, until we have this piece done. And I found that when I added stuff in, it promoted new errors. That's what it did. And the new errors are the ones we're going to fix one at a time. So here's some new stuff for our agent. So our agent added some new, kind of pieces. Again, I know this is kind of backwards compared to how you would do it, but we're adding new material in here, and I'm just trying to fix the stuff that's already in. So let's start off with our agent.h. So again, agent.h is where this is being added in. You can see that there's no flee, move to cover, wait behind cover. Those are the new actions that we're adding in, and agent doesn't have those right now because we haven't programmed them. Let's add them in. So again, I would say let's go to decision. Let's go to our core, and agent.h. Let's fix those up right now. And agent.cpp I'll put next to it because we may have to do something with that. And okay, and let's go to agent.h. And in agent.h, let's start from the top. So we have a couple things here. We have our GLM vec4, navigation object, and action state. And what we've done is for lab 7, added for lab 7, we had an event manager and an obstacle. Those two things that are up here. Okay, that was added in before. And let's scroll down. We have the draw functions and getters and setters. But notice now we have some new things that we're missing, some actions. We have an attack, move to line of sight, move to player, move to range, patrol, and those are good, but we're missing some other ones. So for lab 7C, new for lab 7C, these are the new ones. Virtual void, flee, right? We have a virtual void wait behind cover. That's the new one. And a virtual void, these are all ones that can be overridden, move to cover. These are all different actions, how they should work. So those are the ones that we're missing. Also, one thing to note, since we're here, let's do some housekeeping. What Alex has added in also is a way of keeping track of agent health. Let's put that in. We can say new for lab C, right? Is a m_health kind of property with starting off at 100 health. So we can keep track of player health. And not just, sorry, enemy, the autonomous agent health. Okay. But of course, with health comes some getters and setters. Let's put those into place now as well. So we're going to do a get and set. So first we'll start with our getters up here. We want to do a get health. So int get health, which is going to be const, as well as a set health and a take damage. And that's going to be just before the action state. So down in here, we're going to say void set health, where I want to set the initial health to whatever the value of the health is. Well, if I can spell value. And finally, a void take damage, which is going to also be a different value, whatever that damage is going to be. So set health and take damage are kind of like setters, and that's why they've been put here. Awesome. So we've got set health and take damage. And of course, what we want to do is program these. So I'm going to go up to the top here and go to agent, go left to here and say generate definitions by declarations. We do not want to generate draw, update, and clean as they are virtual void functions, right? So we're just going to generate get health, set health, and take damage. Alex did it inline in his examples. Let's go into finish. And when I did that, you can see that I have get health. Well, for get health, we're going to return m_health. And for set health, we are going to say that m_health is equal to value, which is going to change value to a const. And m_health, m_health minus equal to value when we're taking damage. Again, this can be const. So there we go. All right, so that is our getters. Those are our getters and setters for this. In the agent.cpp, let's just make sure there's nothing else. I'm just going to scroll up to the top here. So we have this stuff that we left here before. We have our new, and this is inside of the agent constructor. So nothing new in the agent constructor. That's good. And really, there's nothing new other than the stuff we've added in. We've updated our whiskers, which we're not using right now, as well as checking line of sight to targets, which is there for our agent health. We're also setting as line of sight and all that stuff, and also change direction. So nothing is different here for our agent. Agent should be done at this point. And because we did that change, we shouldn't have any more errors. Again, I'm just trying to fix errors as we're producing or putting together our little application from the stuff we got online. So again, let's just save all and let's do a build, only a build. Okay. So again, this is just something that we want to make sure. So there's no errors, this is where we want to continue from, and we'll put this up on GitHub as our baseline for what we're going to do for the remainder of today. Okay, let's see how we're going here with our build state. Builds. Oh, hey, this is a good sign. Build start, but that means I can run it now, and we should be able to see what we had last time with no movement, really, or it's not going to show us exactly the same thing because there is no line of sight here. This is our close combat agent. Cool, excellent. Still able to be functional, but it doesn't do anything. We're going to add some additional things here, torpedoes that are going to fire, and a bunch of stuff we haven't added in. But for now, this is a great starting point, and I'm going to put this up on GitHub. So we're going to go to GitHub Desktop, and we're going to navigate to 3001 section 400. And now that we've done that, we're going to add, say, added project files for lab 7 part 3, and commit to main. And when it's done, we're going to push to origin. Lots of files, 1,045 changed files because we've added a whole new project again. Push to origin, this should be pretty good. So why did I do this? Again, you may just add stuff on to your existing lab, as you're building things. So from week after week, that's totally fine to do. But you can see that this is, for the most part, ready to go now. Okay, great. So this is good. I can close down Git cracking because we're not using it for this example. All right, and let's go back to what Alex has given us in instructions. So we've kind of done this piece. That's our first part. Let's talk about our range tree diagram and node layout. Well, what Alex has done for us is he's really spent some time, kind of laying out what our project is going to be like. And I've heard for some other people in the first section that I've worked with today, that they said, hey, you know what? I didn't think that it was necessary or really even that important to do a diagram. And then when we started coding the actions, I realized, yeah, you know what? Diagrams are pretty important because I don't know where I'm at. And where I'm actually going to use this diagram when we're building things because it's a good way of keeping track of how we're doing. So this is the new decision tree that we're going to be using for the ranged combat enemy. This is the new one that we're using here. And the ranged combat enemy is very interesting in that it starts with health that's greater than 25. So if his health is greater than 25, true, we go through here, you can see that they've been marked as alarm conditions. If the health is not greater than 25, then we should interrupt what we're doing and move into a flee state or a flee action. Take the flee action. You could code this. We've done it with a decision tree, but you can certainly use other structures. For example, you can combine something like this with the state machine, and that would be probably another way of doing it. But to keep it simple, if health is greater than 25, then, okay, fine. Is the enemy hit? Did we hit the enemy? No. Then has the enemy been detected? No, then keep patrolling. So we're in patrol state, and it keeps going back to the top every range, every round. So do we have greater than 25 health? Yes. Keep going, keep patrolling, keep patrolling, keep patrolling in this kind of loop that we're doing here, right? How about if the player is detected? Okay, now we're going to go into, do I have line of sight? If I don't, then move to line of sight. If I do, move to the proper range, right? And if I'm in the proper range, well, then guess what? Attack. If I'm not in the proper range, keep moving to range. Okay, so that's kind of the left subtree of if the enemy's hit. Okay, if the enemy is hit, well, what happens to the enemy? The enemy does the enemy have line of sight with the player? If they do, then you know what? Move to cover. If they don't, that means they're already behind cover. Let's just wait some time behind cover. And that's how this thing works. One thing that we also mentioned was that when the enemy has been detected the first time, they're always detected. That means when the target has been detected, they're always detected. It's not going to change. So one thing that's in assignment 4 is it says if the enemy's been detected by line of sight or radius, then if that's true, then they're like a Terminator. They're going to come after you until either you hurt them or they've killed you. That's how the assignment for range combat and close combat enemies will work. Okay, so that's this piece. So that's we're going to use this for our our plan. This is our plan for the rest. How about how the torpedo sprite works? We kind of talked about that a little bit. Let's add a new event in the play scene using the F key, and we're going to spawn a torpedo from the Enterprise, and it'll add a new vector, and we're not going to clean this up. Obviously, there's some stuff that's going to be missing, but it's going to make a really neat little noise. Let's try this out and see how this is working. Okay. So what I want to do is let's go and add the torpedo in. So in the scene, we're going to go to the playscene.h first. And whenever we add anything in, we want to kind of mention that, we need to make a reference to the torpedo. So right now we have a new for Lab 7, a background decision tree, a close combat enemy, and a ranged combat enemy. We're going to enable the ranged combat enemy and disable the close combat enemy for now. So I'm going to kind of do, the new one, of course, is the torpedo. Let's go and include a new torpedo.h. I'm going to start with the ranged combat enemy as opposed to the close combat enemy. So down in here, as we scroll down, we have some game objects, and we're just going to disable the close combat enemy this time and enable the ranged combat enemy. And as we scroll down, we have obstacles, but we can also add some torpedoes. We're going to say that we have a new vector of torpedo pointers that we're going to call M_P torpedoes, which are like photon torpedoes in this case. The rest stay the same. Okay. So now that we've added torpedoes, we have a torpedoes array, a managed array, which is this vector. Right, let's add them into the scene. So playscene.cpp, how do I add them in? Well, first let's fix our problem. We just changed from a close combat enemy to a ranged combat enemy, which means we have to recast our ship as a ranged combat enemy. Let's fix that problem right away because we're going to be testing the ranged combat enemy today first. I want to get that done. Up at the top, let's see what we need to change for the stuff that we're doing. Thank you. So in the playscene.cpp, let's go through it and see if there's anything we need to change or modify or whatever. So we have the event manager, that's nice. And at the top, here are some additional changes. So we've removed all of this stuff. Okay, and I'm just going to just delete all this stuff. Let's just clean all this stuff up right now. One thing you notice that there is no line of sight right now. We're going to add that line of sight stuff in later. What I'm going to do now, though, is as I scroll down, we'll just clean that area up. As I scroll down, I'm going to add in that kind of a bullet firing or a another event. So I'm just going to grab one of these current events that I already have. And we're going to change the scan code from 2 to F for the F key, right? And what we're going to do in here is we're going to instantiate a new torpedo. So we're going to say, let's do a torpedo will fire here. That's where it's going to happen. And the way we're going to do it is M_P torpedoes. We're going to push back a new torpedo object, right, with a speed of 5 pixels per frame. And what we're going to do is we're going to say torpedoes. We're going to look at the back, the last torpedo we added in. We're going to get transform.position, and we're going to say that that is equal to the M_P targets .get transform.position. So what this does is it says, hey, let's make a new torpedo, add it into the torpedoes array, and then what we're going to do is we're going to look at the last torpedo we just added, that's the back, and we're going to set its initial position to the target's position, because the target in our case is the our Starship Enterprise, and that's where the torpedo is going to fire from. Excellent. Next, what we're going to say is, hey, Sound Manager, let's play that sound. Well, we haven't really set that up yet, but we will. And we're going to play the sound, not play music, play sound that is called torpedo. We haven't set this up, and we will because we have to add the torpedo to the sound manager. Also, we want to add our torpedo to the scene. We're going to say M_P torpedoes back. So the back, the last torpedo, and we're going to set the layer number to 2, so that's the order in layer to 2, and that is our F key. So whenever we press the F key, it's going to generate a new torpedo. This is instantiate a new torpedo and add it to the array, which is what this is, because a vector is kind of a managed array. That's what's going to happen. And then here we're going to set its initial position. Set initial position here. And then we're going to play the sound, play the torpedo sound. So those are the things that are happening. Okay, and then add the torpedo to the scene. Add torpedo to the scene. So things that are missing is, yeah, we fired it, but then what happens to it? It goes on forever. For our case, it's okay. Like Alex said, we're not cleaning up. Down into the start method, or the start part of the scene, we need to to add our new torpedo sound, which we haven't done. So we're going to do that here. We're going to say that just like we've done it's an impulse sound. That's a sound effect. We're going to say, let's go and add in the torpedo sound. There's the torpedo.og. We're going to call it torpedo, or we save it into the sound manager, right? And what Alex kind of likes, I think, is the Mutara sound effect. So let's just put that back in. We're using the Klingon sound effect before. I'm going to just cut this out of here and put this here. And we're not going to play both sound effects. That's kind of weird, or soundtracks. We're just going to play one of them, which is going to be the Mutaran soundtrack. All right, and like so, because that is for our ranged combat enemy. Nice. All right, good. So now, without further ado, we should be able to fire our torpedo. All right, let's try this out and see if it works. So, play. And we'll see if there's errors too. Any errors, anything we missed. And I'm just going to turn on the sound so you guys can hear it as well. Let's share sound. And you can see that sure enough, if everything goes well. Oh yeah. We have a nice crash-orama. Okay, so this agent has line of sight is what's causing it. And it's on line 44 with a line of sight condition. All right, so that is new.
I don't know that one.
I don't know it either. So
I Don't Know About You by Chris Lane from Apple Music.
Yeah. No, don't play that. Alexa, stop. Don't know how that happened. But anyway, so that is an issue. So that the only thing we added in right now, we played before, but somehow it just stopped working. So, that's interesting. let's check some of this code out. Before we fire everything, I'm going to go into decision. This is awesome. I love mistakes like this. And let's take a look at some of the actions. So the actions that were added in were attack and then flee. We got these actions working. There's no error here. Move to cover. That's good. And then move to line of sight. That's excellent. Move to player action. That's good. Move to range action. And then patrol action. These are all things that are in play and working. And wait behind cover. So those are all the actions that we're doing for our game so far. Awesome. Let's just close all that up. And the only thing we did really was we just added in the torpedo, but it said something about agent has line of sight. So let's see if we mess something up with the agent. And well, yes, we did, because we changed to our ranged combat agent. So under agent, we went to our ranged combat enemy. Ranged combat enemy is a virtual public agent. Let me just make sure that that is true, because we are kind of stepping ahead of ourselves just a little bit. Just want to make sure that there's nothing that is making this different. Public virtual instead of virtual public. That'll be okay. And yeah, so has line of sight. We declared patrol, move to range, get tree, and that's a beautiful thing, but I think there's things missing from the ranged combat enemy right now that is doing that is causing this thing to hang. And you know what? Just to move on, because we're going to fix the ranged combat enemy in a second anyway, let's just move back in our start method. Sorry about that. Let's move back to our close combat enemy, because that's the one that's kind of working right now. The ranged combat enemy has been going to change, and that's the one change we made that killed our game. Let's go put this back the way it was. And I just want to make sure that there's nothing else that's in here, because that, again, all I did was added that one piece. I think we should be able to run now. And we'll come back and fix the ranged combat enemy in a second. There we go. Okay, there we go. That was the issue. So now we can see that that's true. But now what I can do is if I move the target back, right? Let's say over here, then I should be able to fire a torpedo, right? That is definitely weird. That looks different. Awesome. Looks like it's spamming the torpedo over and over again. Interesting. So what did I do wrong? So yeah, let's say, so we got the torpedo. Let's go back to the torpedo and check it out, because that was not done the same before. And I love when I make these little errors. Play scene.cpp. Yeah. Okay. The position, we play the sound torpedo. We added this in as a new torpedo. We push back to torpedoes. We play the sound and we did a torpedo back to. That's good. I don't think there's anything different. I mean, it does play. It just looks weird. Huh. And I'm just going to make sure there's nothing else that's missing here from our scene. Torpedo, set volume, and did I have everything done with the torpedo itself? I think so. Let's go to, that's weird. It plays, but it plays oddly. And what I mean by that is if I can tell by looking at it that, let's go to torpedo.h. Okay, so it sets up a float speed. It starts off, and what it does is it builds animations. The way that torpedo works is there is a current action animation state. It has two of these files we talked about before. One of them is plays multiple times. Yeah, it looks like it. Again, we'll get to that in a second. Yeah, so what it does is there's two parts when we load a sprite sheet, and this is something that Alex has to cover anyway. One part is this part, which is this is the data sheet, right? Okay. And this is the actual texture, the texture atlas, all right? So the texture atlas itself is, if I can spell texture atlas, which seems like I can't spell anything right now, which is also a fancy name for a sprite sheet. So texture atlas and load sprite sheet, there's two parts, a data file, and the data file gave us our instructions on where this is. The torpedo sheet is what this thing is called. We save the torpedo sheet as a reference in the texture manager, and then what we're doing is we're setting the sprite sheet for this object, because torpedoes are a sprite. That's what they are. Then we set the torpedo sheet itself as the sprite sheet that we're getting from the texture manager. Each sprite is 64 by 64, just as we saw here. These are each 64 by 64. And then what we're doing is we're setting up the type as a projectile. We are in the draw function, where in case we fire the torpedo, we're going to play the animation, which is from the torpedo sheet. We're going to use the torpedo sheet to play the animation that's called fired. Fired animation is down here, and each time we create the animation inside the build animations method, where we create a temporary animation object called fired animation. It has a name, fired, and then what we do is we build each of the animation frames by, the frames is a vector of animation states, basically, or animation frames. And we push back each of the frames, fired 1, 2, 3, 4, 5, 6, 7, 8. That's how many frames there are here, to the animation. We construct the animation, which is the fired clip. And then we set the animation, we set an animation called the fired animation itself to the torpedo. And then what we do is once we've done that, we can call the animation that we want to play, and that's what we're going to draw. We're going to draw it at X and Y coordinates where the current object is. You know, the next part is the speed. So it says, so the first thing is the sprite sheet. The second thing is the animation itself. What is it called? The fired animation. X and Y coordinates, the speed factor. So how fast the animation is playing, how fast it's flipping frames. And the angle, right, which is 0, as well as alpha transparency, which is fully alpha, and is it centered or not, which is by default true, by default false, and we set it to true. Okay, so that is the little switch case for our current animation state for the for this thing. So that's pretty good. So it's not in the torpedo. That's the problem. Maybe it's in the CPP. Maybe we did something different for the scan code. Let's go there and check it out. So yeah, scene.cpp. So it's playing perfectly in the other one. So oh yeah, I'm using his key down. This should be key pressed. Haha, key pressed. That's a mistake. So the difference between key down and key pressed is key down, what it does is it does it multiple times. Key pressed, what happens is it does it only once. Okay, so those are the difference between one and the other. And now if I run it one more time, you can see that we will cover the same thing. So that's the difference. So if I press, I get one. Right. One thing to note is I can kind of spam the torpedo enough. I'm just going to put this on this side for now. And let's move the target way back over here. I can spam the torpedo enough where I don't have any channels left. So you can see that there's no free channels available to play our special effects. So that's something that we have to work on as well. So we only have a certain amount of channels we can do while we're launching our torpedo. But that's pretty cool in terms of our animation. Let's put that up on GitHub. All right, so again, we can say that we added torpedo fire capability to target. Okay, so commit to main and push. That's the torpedo fire done. Okay, but definitely something looked wrong. Something didn't look right. We saw it. Why? Because we were spamming, because we were pressing the wrong kind of event. And it also gives us a chance to talk about the torpedo and how it works. Excellent. Let's go to the next step. So now that we have the torpedo, we're going to talk about the new stuff in the agent. We've kind of already done this and prepped when we put the project together. Let's take a look at that right now and make sure that we're all good to go. So let's do that. Yeah. So let's go into that agent.h and take a look and see what it looks like. So I'm just reading some more comments. All right, so agent.h, let's take a look at that. It's pretty awesome. So we're going to go into decision. We're going to go into core. We're going to go into agent.h and agent.cpp. And one thing we've done here is we've already done this work. So we've already gone and done the attack, move to line of sight. Those are from last week. Flee, wait behind cover, and move to cover. Those are the new ones. And we really have done everything we need to do for the agent. And we kind of made that when we put together our project. So this is kind of done. All right, we've done this one. Next, action and condition nodes. So what Alex has asked us to do is check through all of them, and I kind of did that already when we checked the problems. So that is the issue. So we're down into the ranged combat enemy mode. All right, so we already have all the action nodes, and all that stuff is working as it should. So let's get into RangedCombatEnemy.h and .cpp. It says duplicate it, but we already have it. And it says, let's add the new action functions that we haven't added in, as well as modify the new build tree. And this is the thing that took me the most time the last time. I think we're going to have plenty of time to do it this time. And then we'll fix the play scene and fix it up. Okay, let's get it done. So back to this. So we're going to work on the agent. I'm just going to close all of this down. I like to kind of keep it clean as I'm working because there's a lot to look at, and it's already confusing to the max when you look at this for the first time. So decision, we're going to kind of close these off, and I want to start thinking about the only agent that I care about right now, which is my range combat enemy. Range combat enemy has some things we need to add. Okay. So let's go and start thinking about these range combat enemy things. Okay, so I'm going to start off with the .h, and from the top, let's take it from the top to make sure that everything is good. So it's a public virtual agent, check. We've got our getters and setters. We have only 2 actions that are mentioned here. Patrol action and a move to range action that are updated and overridden. We need the rest of them in order for this to work. So let's add them in. So here we go. So a void, and we're going to start off with the move to line of sight action, which is an override. We're going to go void, and we're going to go to move to range action, which would be next. Patrol, flee. Let's do the flee action. We didn't do that one yet. Flee, and let's put this one. You know what? I want to put this at the top, just because adhere to what we saw before. So flee, patrol, move to range, and then move to line of sight. Let's move to line of sight first, just to rearrange those things, just to see that we're adhering to what Alex has had. Void, wait behind cover action. Okay, we're going to define that. And void, move to cover action, and we're going to do that. And then finally, void the attack action. So those are the attack actions. These are all things new, again, for and updated for Lab 7C. Awesome. The rest is pretty good still. We have our ability to move and set a waypoint and all that stuff. Nothing else changes, but those are the first changes we have to make to our enemy or range combat enemy for this lab. Okay, great. Now at the top, we're going to go to range combat enemy and click the little hammer. It's going to say generate definitions by declarations, and we're going to add in flee, move to line of sight, wait behind cover, move to cover, and attack. Whew, finish. There they are. And what Alex has done is actually interesting. He's made it easy for us to copy paste some of these things, which is actually really a good idea. I'm going to start with flee, and then we'll do the rest. So it's going to start off with an action state, which we're going to set up an action, which is the flee action. Okay. And we're going to say if our get action state, if that is not equal to whatever the action we stated at the top, the action, if it's not that action, then we want to initialize that action where we set the action state to that action that we mentioned. Okay, now this is very interesting. The ranged combat enemy and flee, it's almost like we can kind of save time. It says the exact same thing. Maybe there's a way in the future we can refactor this so that we just pass in the action state to whatever the action is, and it does, because all this is pretty much the same. The thing that changes, and this is the key, is what is the action to perform? Action to perform. That goes here. And we're not giving you this action to perform. That's for you to do, right? But that's what the flee action would look like. Now, it also gives me this thing where it says, hey, maybe what you want to do is make it const. I'm okay with that because we're not changing that. It also says, do you want to move it to the inner scope? And it's going to look like this afterwards, where it says const action is equal to flee. You know, we're kind of setting it here, and then we're doing something. I personally don't like this structure, so I won't use it. All right, but nothing wrong with it. It just moved it in here first as 2 conditions, which is kind of interesting that they would tell us to do that. Okay, so let's copy this part, and we'll go into move to line of sight now. This is why I said that Alex made it easy for us, and we're going to say move to line of sight, which is this one, right? And we'll just copy it again and wait behind cover. That's this one. Wait behind cover. Awesome. And let's do the next one. You can see how this is. Move to cover. Move to cover. And then we have an attack action where we say, okay, attack. And finally, there's the other ones that we had before. I'm going to replace these ones just for completeness. I'm going to call this the patrol action. And we already have an action, which is move. I'm moving with when I'm patrolling. So I'm going to get rid of that part. This part is the same though. So let's just grab this one and move to range. So move to range, right? That's that part. And that is basically all of our action functions. So that's what all those things mean. Range to combat and move to range and patrol and all that stuff is part of our ranged combat enemy. Again, theoretically, I'm just going to put it out there that, maybe this doesn't belong here. That what we can do is we can kind of add these action methods somewhere else, right? And that there is a suite of actions that we can attach to the enemy or anything that we want. And they're not, because we would have to copy a lot of this over and over again for our close combat enemy, then that is something that we could do differently. And what we can do is for any kind of action, maybe what we could do in future, as a future state, which we're not going to do right here, is have two parts. One, I want to perform an action. What is it? It's going to be the wait behind cover action. And what is the callback that I'm going to perform? What is the action that I'm actually going to take? Make that a callback. That's part of this thing. Again, a little bit more complex than this, but maybe in the end, as a refactoring, a little bit less duplication. See how that goes. I don't think we're going to have time to make that change this semester. All right, so that is pretty cool for that part, the actions, and that is what we were told to do. When we go to this, we added all the new action functions. Done. Right. Next, change back the sprite back to Reliant. Well, we've already done that. And modify the new build tree. Oh, this is going to take long. Ooh, oh, this is terrible. And why? Because it's so much more complex than before. We're going to start off with this part, which means we're going to reset our node. Now, what I'm going to do, which is slightly different than what Alex did, is I'm going to go level by level. Okay, so I'm going to do all these levels first like this. So I'm going to start off at the top level, right? And I'm going to literally go from this one to this level, and then to this level, and then to this level, and so on. So it's slightly different. For the most part, we're pretty good until we get to about here. Okay, and then I jump over to this. I just go like this, right? And then like this, and then like this. Okay, so that's how I'm going to do it. But again, you can set this up as long as the roots, the parents of the left and right subtrees, as long as they're correct, it doesn't really matter how you add them in, because they'll be added into the right position. Okay, but they have to be added in before. If I was going to add this one in, I have to have this one added in before in the tree, before this one gets added in. Why? Because it's going to hunt for this thing when we actually go traverse the tree. And if it doesn't find this as a root, it's going to say, meh, sorry, there is no enemy yet because we haven't added it in yet, right? So it's important, the order, and I'm going to add it in the order that I add this one, then I add these two, I add this one, and then I add these two, right? Okay, let's get back into it. Because enough talk, Conan says. And let's see, and go to the next part. All right, so yeah. So we have some stuff. Some of this we can reuse, some of this we cannot, right? Because the new stuff is, well, it looks different. And it's pretty massive. So let's take a look and see what happens. So the first thing is, for our conditions, the first thing is the root node. What is the root node? It's no longer the line of sight condition. It is the, I'm going to go switch back to this, it is the health condition. Right? That's the new thing that's going to happen. So the enemy health condition is what I want here. And I'm going to say, let's set the enemy health node. Let's set that up as a new enemy health condition. Right? That's what's going to happen here. Enemy health condition. That's the first one. And we're going to set that the root of the tree is the get enemy health node. That's what we have as the root of the tree. So this is the first level. Okay. Now we want to do the left tree and the right tree. The left tree, again, if we go back here, is the flee action. Okay, so this is an action which we treat slightly different when we code it compared to the conditions. So again, I'm going to code this from scratch. We're going to say that tree node pointer is, we're going to call this flee node, which is a new m_tree, which we're going to say that we're going to add node. This is very similar. So the root is always here first, get enemy health node. And then we are going to make a new flee action. A new flee action. And of course, that it says, hey, we don't have fleeAction.h. We're going to get back to that as in a second. And we're going to go to the left tree node. So fleeAction.h, we're just added in, right? So that gets added in nicely. And then what we're going to do is we're going to say flee node. That is set agent for the flee node to this, because this is the agent that we're going to use for this flee node. And then m_tree, we're going to get tree and push back the flee node. Okay, so that is our left subtree. Okay, I'm just going to push these down, and we're going to do the right subtree now. The right subtree is going to be the enemy hit condition, right? Because this is this part right here. So we did this one. Now we're going to do this one. Okay, so the enemy hit condition is a condition type. It looks very similar to how this is coded. Let's just grab all this and change it so that we need it. Actually, I'll grab even this one because this one looks very similar and it even has right tree node in there. All right, so cool. So what we have to change is we can't set a ranged combat. We're going to set the set enemy hit node. And that is a new enemy hit node, enemy hit condition. That's what that is. That's the new enemy hit condition. And we're going to add a tree. Well, where does it get added in? It gets the root is the enemy health node. That's that one. Okay, that's the root. And then we're going to have a the get enemy hit node here. Get enemy hit node is what we're going to do. That's the right tree. And we're going to push back the enemy hit node here. So get enemy hit node. Get enemy hit node. There we go. Yeah. Okay, so that's the right subtree. So far we've done this level right here. The next level is going to be player detected. That's going to be the left subnode, right? We don't, again, have anything like that. So we're going to look at the set player detected node on the left. I'm just going to take this same thing, this set player radius, which is very similar, which we may not use. So grab this whole thing here, copy it, and use that as the left subtree. So instead of set radius node, it's going to be set player detected node, and it's going to be a new player detected condition, and the parent of this one, player detected, is the enemy hit, which is what we just did. So this is the enemy hit node, get enemy hit node, as the parent. That's what this is. And then we're going to use the get player detected node, player detected node, there we go. And we're going to use that, and we're going to put that into the tree. Done. Left tree node done. So that is this node right here. How about the right tree node? This is the right has line of sight node. That's a new thing. So I'm going to do it. It's going to more look like this than anything else, but let's just code it from scratch. So we're going to say something like, hey, line of sight condition pointer. We're going to call this the line of sight node right. And this is going to be equal to a new line of sight condition. Excellent. And what we're going to say is m_tree, we're going to add node. Let's go back. We have a thing for that. This is going to be the right tree node. So let's grab one of these because it's almost the exact same. And we're going to add node. And in this case, we're going to say that the enemy hit node is this one. So enemy hit node, that's going to be the parent. And this is going to be the new line of sight node right. This is the one that's going to be that we're going to add in. And the line of sight node right is going to be the right tree. And what we want to do here is, because we want to do something like this, because it is an action, kind of. So we're going to say that the line of sight node right is we're going to set the agent for that to this agent. And then we're going to add it into the tree. Okay, so we're going to grab all this and add that in. And we're going to say get tree push back, and it's got to be the line of sight node right. We can get kind of rid of all this. Line of sight node right is the one that's going to be added into the tree. So now we're at this part. We've added this one. We've added this one. Okay, now this is where I depart from what Alex did. I'm going to add this one, this one, this one, and this one in that order. So patrol first. So do we have a patrol node? We do. It's right here. Let's grab that patrol node, but we need to adjust it a little bit. Okay, so that's an action that we're going to do, because actions and conditions are going to be kind of mixed together in this decision tree. And the reason for that is because of the way we've restructured it, so that way we can do everything. So if I have a patrol node here, I don't need one here. I'm just going to get rid of that one, so we can't use the same name. So patrol node is interesting, but its parent is the player detected, right? So that is the one on the left tree. So get is the set player detected. We're going to use get player detected as the parent of the patrol node, right? So that's this one. New patrol action, left tree node. We don't need to cast it anymore because that was something we needed to do before. But now we've realigned stuff, so we don't need to do this anymore. We're going to push back the patrol node. So the patrol node is done. That's this part. Has line of sight. And has line of sight is a line of sight node, which is the left line of sight node. We did the right one. So this is kind of the same as the other one. Let's grab that right line of sight node, this one, and we'll just make a new one where we're going to call this line of sight node left. And I'm just going to replace the rights with left for now. Copy paste a couple times. One thing is that the enemy hit node is not the parent. It is just like the patrol node, the get player detected node. Why? Because has line of sight is the parent is player detected. That's why we put the get player detected node. Okay, so we've done these two. Now we're going to jump to wait behind cover. We don't have a wait behind cover thing, so we're going to add that in. This is new. And let's get to that piece. So it's going to be a new tree node, similar to what we did here, all right? But we're going to code it by hand. So we're going to say tree node pointer, and it's going to be called wait behind cover node, which is equal to an m underscore tree add node, similar to what we've done before, where the line of sight node right is going to be its parent, right? Wait behind cover, line of sight node right? And then it's going to have the new wait behind cover action. We don't have this action because we haven't added it in. Let's add the include. There we go. And this is going to be the left tree node. That's what that is. And that kind of takes care of that line right there. Wait behind cover. Now the rest is like the set agent and the pushback. So I'm just going to grab these two lines here and replace those with wait behind cover. So wait behind cover, the agent is this, and let's push back wait behind cover. So that's wait behind cover, and that is this one right here. We need to do move to cover, and that's the next one that we need to do. Move to cover is like wait behind cover, almost exactly with different words. I'm going to copy paste that one this time around. And let's push this back down here a little bit so we don't need to see that. So that's wait behind cover. This is move to cover node, right? So has cover in there. We're going to say this is called move to cover node, right? I'm going to replace these words, this one and this one, and this is okay, but this is going to be the right, just before we forget, the right tree node, almost perfect. And this is not the move wait behind cover action. This is move to cover action, if I'm not wrong, because we kind of named it the same. Move to cover action, right? And if there isn't a move to cover action, we can add in the .h. There we go. And we're good to go with this one. There's move to cover node. So wait behind cover, move to cover. I think we're doing well, right? In terms of where we are, that's right here. Now we're going to go to move to line of sight, which the parent has the line of sight left. Right, so move to line of sight. Do we have something like that? We do, it's this one. So we're going to grab this node right here, cut it out of here and put it up here. Right, there is our move to line of sight node. However, the parent is the line of sight node left, which is what we want to put in here. So line of sight node left, which is up here, that's going to be the parent for this one, right? And move to line of sight action is the one we want to do. It's the left tree node, not the right tree node, left tree node. Okay, there we are. And of course, we don't need to cast it anymore. So we can say goodbye to this one And for the most part, move to line of sight node is done, right? There we go. That's this one. Now we're going to do the within range node. Okay, this is a move to, we're going to do the set range combat node, right? That's what it's called. And that is this one. Okay, so we already have this set range combat node, and it's already the right side. So we're going to grab this one, put it over here, and set range combat node, which is this one within range, right? That is this one. So we're going to change the parent to that. Line of sight node left. Get range combat node. This is the right tree. It's in the correct order, right? And we're going to push this back to the get range combat node position, which is now this one. Okay, now we've done this and this. Now we need to do move to range and attack. Okay, move to range. Do I have that? We have move to range and we have attack. We don't need set radius node. Let's get rid of that because we're not doing set radius anymore. Move to range node. Move to range is the left subtree, and it's already set up as the left subtree. Let's just get rid of some of this. However, the parent node is incorrect. The parent node should be the get ranged combat node. So that is the, hey, look at that, get ranged combat node, left tree, move to range combat, move to range. That's this one. And hold on a second. The only thing we need to change is this. We can get rid of that stuff. We don't need to do that anymore. And move to range node. How about the attack node? The attack node, well, that is the get range combat node. That's this one. And new action, that's the right subtree. It is. And okay, we can clean this up. And that is, my friends, that is the decision tree for our range combat enemy. However, one thing to check, and this is important to do, let's go through and make sure that we have all the things in the right order. I kind of do a recheck. I know this takes an extra second to do, but I think it's worthwhile. And the reason why is because if we make a mistake, we want to go back and check it. So let's go in the first place. So set enemy health node, that's this one, and it's an alarm condition, and it's going to be the parent of all nodes, right? So we're going to go back to this one. We're going to push back the get enemy health node to the root of the tree. Awesome. Flee node is the left tree. That makes sense. And it's going to use the get enemy health node as its parent. We're going to set the agent to this, and we're going to push the tree node, the flee node, into the tree. Excellent. That's done. Check mark. Enemy hit. Enemy hit node. Okay, cool. That's this one. Enemy hit node is a new enemy hit condition. Nice. Because it is a condition node, right? And we're going to say that we're going to add it to the get enemy health node. That's this one. That's this one. As its parent. Get enemy hit node. It's kind of the same name. You got to be careful there. The right tree node is where it's going, and we're going to push the get enemy hit node to the tree. Awesome. The player detected node, we did that one. Player detected condition, it's a condition node. And we add node the get enemy hit node, which is this one, as its parent, right? And get player detected mode is the child, and it's the left subtree, which it is, okay? And we're going to add the get player detected node to the tree. Now we have the right line of sight condition. The right line of sight condition is using the get enemy hit node, which is the same as this one, but it's going to be the right subtree, and we're setting the line of sight node right to the set agent this, which is this particular class, right? This agent. And then we're pushing back the line of sight node right to the tree, which we've done. So we've done all of this. And again, I'm just checking over it one more time just to show you. And then the patrol node is going to be here, right? And just a fast track, it looks like the left line of sight node is here. Wait behind cover is here, with line of sight node right as its parent, right? And move to cover action, which is here, with the line of sight node right as its parent, right? Which is cool. And I think I've got everything, guys. Move to line of sight node with the has line of sight node left, right? Left tree node, and yeah. And I think I've got everything good to go, because there's a lot of copy pasting, and I think we did good. I'm just double checking. It's always good to do this when we're building a decision tree. that's this complex. Now, future fit. Maybe we're going to have something visual for future classes, but for now, I think this is pretty good. Excellent. Let's save this and let's put this up on GitHub because we've added the, I know we haven't tested it yet, but I want to put this up because we've got a lot of stuff happening. So we'll say completed the ranged combat enemy agent version 1. Okay, actually this is version 2. Version 1 was last week. Went to main and pushed to origin. Awesome. Okay, now let's test it. So let's go back to Alex's example. It says modify the new build tree, and we made a commit. Now we need to test this thing, and now we're going to switch over to our spaceship to our ranged combat enemy. Let's do that now. Okay, so let's go into our, let's close this up. Go back to our scene and go back into our playscene.h. And let's see if we're going to get any errors. This is the test, right, where we set up our ranged combat enemy as our spaceship. And in the playscene.cpp, we're going to go back to where that is. We have an error. And we're going to just swap out a reference to the close combat enemy for the ranged combat enemy. Now, this should be working. Let's see if that works. If I just run it, we're just going to do the regular thing that we've done before with our ranged combat enemy. If we don't, we'll have some errors to fix, and that's okay, right? Because we're going to go through the errors, and we'll go through the call stack and see what the problem is. And good, right? We're good to go. We're excellent. Now, one thing that's missing is some other things for line of sight, but we don't have any issues, which is the main thing. And let's also take a look at some other things, right? Notice how it stopped. Well, it says performing the patrol action because it has no way of knowing when I'm close enough to the player anymore. We haven't set that up inside of the scene. Okay, so that is going to continue to perform the patrol action, well, forever. Let's make that change now. So to test this, and the playscene.h, let's go back to the playscene.cpp. I think we've done everything we can in the playscene.h. We're going to go back up to the update function. And in the update function, for now, we're going to just worry about the ranged combat enemy. So this is the ranged combat enemy line of sight. We'll do the close combat enemy line of sight after this, because I want to take care of this first. So m_p spaceship, we're going to say, well, that we're going to use get tree, and we're going to get enemy health node, and we're going to say that let's set our health right now to m_p target, and we're going to get health, and this is something that so why doesn't this compute? Well, I'll talk about that in a second, because we're going to start, kind of calculating if we've done damage, and get health won't work. And the reason why get health won't work is because our target is still a display object and not an agent. Let's change that. So again, inside of the game objects, we'll go back to our target object, and we'll change our navigation object, right, to a public virtual agent, which will allow me to set health, because all agents have health. So save. And if I go back to the play scene, now that is not an issue anymore. Again, this is just all set up for our health test as well. We're going to do that too in a second. m_p spaceship, and we're going to say, let's set this up, get tree, and we're also going to get enemy hit node. We're going to set this up so that is hit to false, because this is kind of the default condition. Again, is hit would be different for A4. This would be different for A4 because you're going to detect if it's hit. We're saying it's not hit right now by default every frame. But what if it is hit? Then you're going to follow the, kind of the decision tree to say, well, if I'm hit, just like we said before, then we're going to go to line of sight. Do we have line of sight? Yes. Well, then do one of these two. Okay. So that's what this is going to be. And we can test that condition. And then we're going to say, here's the one where we're going to actually check agent line of sight to target when we start off with the spaceship. And we're going to go M_P target and M_P obstacles. This is what we've kind of replaced from before. Okay, so this is the first piece. And I'm putting this in here because these are the first pieces that we want to have. We set the line of sight. Other things that we're going to do as well to help with this is we're going to set up a temporary distance or variable. We're going to say util distance, and we're going to get M_P spaceship get transform dot position. From there to the M_P target, that's our enterprise, get transform dot position. What's the distance between those two things? I mean, one of the distance so we can calculate, well, if I'm within a radius, whatever that radius is. We can say that is detected, which is a Boolean, right, is equal if the distance that we're calculating between these two things is less than 450 pixels. So we're going to say just outside, of line of sight range, right? That's what that is. And that is really the radius. So radius detection just outside line of sight range. So we've been detected because we're within 450 pixels, but we haven't been, we don't have line of sight yet. Okay, we're out of line of sight range. Okay, that's the first thing. And then we're going to say that, well, M_P spaceship get tree, and we're going to get player detection node. We're going to set detected to whatever is detected is. If this is true, right, then this is going to be whatever this is good. This is going to set that condition up. If my distance is less than 450, then is detected is going to be true. If it's greater than 450, then is detected is equal to false. And that is going to change, every frame pretty much. Now what should happen is if I'm detected, I'm always detected. And that's something that we are going, that would be different as an example for your assignment 4, because once you've been detected in assignment 4, you're always detected. Here, you're detected or not detected every frame. Okay. Next, bool in range. We're going to say that is if the distance is greater than or equal to 200, and that is within the shooting range. That's what this is. If I'm within shooting range, if my distance is greater than 200, so I'm far enough away, and yet the distance is less than or equal to 350, right? So that is, just under line of sight distance and not too close, right? Which is really the optimum firing range. That's where we want to be. Okay, we don't want to be too close because then we can get hit. We can get rammed or something. And M_P spaceship, we're going to say get tree. These are all the conditions. We're going to get ranged combat node, right? And we're going to say set is within combat range to, well, if I'm in range or not. And these things is detected, other than is detected, is going to basically set up all of our configurations to check to see if we're making a decision. Okay. Now notice making a decision is not part of this. It's part of the enemy agent. That's what it is. So we don't make decisions here anymore in our play scene. Okay. So that is the setup for our ranged combat enemy. Let's do that first. Next, we've set up the ability for us to fire a torpedo. We can also do some additional things where I want to do things like, let's do some damage. Let's deal some damage. How does this work? So if I want to deal some damage, this is for testing purposes. I'm just going to grab all this, paste it, change this to a D for the damage code. And what we want to do is we want to say that M_P target, we're going to set health, or we can also, instead of set health, let's say take damage. Let's take damage to a number of damage, let's say 25, right? You can have also alternatively set something like M_P target, set health to something like get health minus 25. It's the same thing. That's an alternative, right? Same thing. Okay. And then afterwards we can just pump that out as an out. So C out targets at M_P target and get health. There it is. And we can say that whatever that percentage is what we want to show. Whatever that percentage is. So 25%, 75%, whatever. And that is our testing to see if when we press D, we just do damage automatically. Okay. Kind of a neat thing. Good test. And the other one is, what if I want to reset everything again? That's the reset number, the reset code, right? Then I would set health to 100. Yeah, that's what that would happen there. So we're resetting the health back to 100. I'm going to say that M_P spaceship get tree and get enemy hit node. We're going to say set is hit to false, so we're not hit yet. And M_P spaceship get tree and get player detected node, right? And we'll say set detected to also false. We're not detected right now. And we'll say that the target condition has been reset. Okay, that's what that is. Or we can just kind of make a little comment like that. And I think that's a good idea too, if we want to reset or give the ability for us to reset our health and so on. Okay, so that's how that works. And that is basically some controls that we're going to use for our range combat enemy. Let's run this thing and see if it works now. And it should be fine because we really haven't changed much. All we're doing is we're adding some additional controls. So again, things still work well. So why isn't this moving? Because, again, this is kind of weird. They're within range, right? So one thing to note is we can probably test for this, but if you see here on the right hand, it says performing patrol action, then it says move to line of sight action. Why? Because our spaceship, the distance between these two things is pretty close, and that's why we're pretty good. Let's move our target around. Let's move it down. And if I move it down, you can see that once I'm out of range, it's going to start doing patrol again. There's our patrol action, and we can turn the grid on to see how that looks. And once we get close enough, right, so either in range, so the distance in range or not, we need to move to line of sight action. We don't have line of sight, but we are within range. We need to move to line of sight action. Okay. If I move this way over here on the left-hand side, right, and let's move it a little up too, so it's going to patrol a bit. And let's see if we can give it line of sight, but no range. So something like that, that looks like this. Okay. Now, be careful. Once it gets to close enough, then you're going to see that here it's good. Let's move this just a little bit up. Just want to test that condition. So we're going to go right here, and then right here we've been detected, right? And we're in line of sight, right? But we're not close enough. Our line of sight distance is just out of range. If I move this down, let's say, for example, I move the target down, then you can see that it turns off, and it becomes move to range action. We want to move far enough away so we can hit. So now we're too close to fire, right? So it wants to put us in that sweet spot where we don't want to be so close. And so the next action you would take is to move your enemy out of here. And you can do it in different ways. If I kind of move this back just a touch, you can say it's just out of line of sight range because it's too far. And so now it's moved to line of sight range. It switches the activity that has to take place. Okay? So that is how it works. Okay, so very nice. very nice the way we've tested it. Any questions around this? So we've kind of set up our ranged combat enemy now, so it works okay. I think it's a good opportunity for us to put it up on GitHub. So let's do that. So we'll say set up ranged combat enemy to work in place scene. We haven't tested out the damage or anything else yet, but we've done the torpedoes. We're going to do that in a second. How about our close combat enemy? I mean, we don't want to deny them. And right now they have no way of detecting or doing anything else that we have to do. And, for that, just going to pull this over here for a second and talk about it. So we've kind of done most of it, right, at this stage. But I want to talk about what happens when, we want to have just going to open up our other notes here. And I wasn't able to do this in the first section, so I'm going to do it now. And really what it is just adding some more information for my close combat enemy. There's nothing for us to change, but in the playscene.cpp, right, let's align it so we can test the close combat enemy as well. All right, so range combat enemy done. Close combat enemy is what we want to focus on next. So again, in the start scene.h, in the place scene.h, we don't need this. I want it switch off, so it's not range combat enemy, it's close combat enemy. Let's switch it the other way around now. And let's go back to the place scene, and we are going to comment out some stuff and add some more things in here. This has to be changed from our range combat enemy back to our close combat enemy. There we go. So what has to change is all this stuff, right? Because our close combat enemy isn't going to behave like this. So this behavior here is what's going to happen when we want to do station keeping, optimum firing range, and all that stuff. But our close combat enemy wants to get close, and this is not exactly what we're giving them a chance to do right here. So yeah, let's get into this. So yeah. So what does our close combat enemy look like? So this is our close combat enemy. And I want to, just for now, comment this stuff out, right? Which it's going to be very similar, but let's think about how it's going to be different. So m_p spaceship, well, that is going to get tree. And we're going to say that get player detected node, we're going to set detected to false. Again, like we said before, this would be different for A4, because A4, you're going to have to, once you've detected it, you're always detected, right? That's the one thing that's going to happen, right? And next thing is m_p spaceship. We're going to say that we're going to check agent to line of sight distance, and we can actually copy that because we already have this, which is check agent to line of sight distance. This part here is going to be over here. All right, so those two things pretty much very similar. Okay. And then we're going to use our close combat node, m_p spaceship, and we're going to say that we're going to get tree, and we're going to get the close combat node, and set is within combat range. We're going to set that to false. So that is the stuff that we need for our close combat enemy, which is different than this part. Distance and all that stuff. The set detected and all that stuff. This is range, right? So this part here is the range. So setting up ranges, right? So this is radius and range check, okay? In range, well, within range is if I'm close enough, and that's okay. As an example, if this part here, if other stuff isn't done the same way, we need our distance. Well, let's just separate this for a second. And I'm just going to comment this out, and we're going to comment all this out. So we're going to make this a comment this whole block out, right? Just to make sure that this works. And again, I didn't do this in the first, so we're just doing it now for the first time. Is detected, and I'm just going to comment both of these two things out because this is for the ranged combat enemy. So this is ranged combat enemy. This is ranged combat enemy. This is our distance check more than anything else, distance. And we are going to, when we start detecting if we're within this part here, this is good, but the detected thing is going to be different. It's going to look a little bit different like this. We're going to say something for our close combat enemy. And this is for radius, right? We're going to say that if m_p spaceship get tree get player detected node get detected, if that is equal to false only, then we're going to set bool is detected, this whole thing here. Okay. And then this one here is going to be put inside of here. So we're going to do an extra check that the only way we're going to do this is if I'm already detected. If I'm detected, then we'll see that, yes, if it's false, then we're going to check and make sure if it's true. Otherwise, we're not going to check this anymore because is detected is always going to be true after this, okay? Which makes sense. So that's kind of in line with what we want. Range, under line of sight, and that would be a little bit different as well because in range, well, we're going to get tree, get ranged combat node. Well, we don't have ranged combat node because these two things would only be for our close combat nodes. So these are going to be commented out too, if I'm not wrong. I think this is correct. And yeah, let's try this out and see if this behaves differently or if I messed it up. And if I did, we'll fix it. Okay, let's try this out and see if we're okay. So we should see the Klingon. The music is the same for now, but at least we'll be able to load everything and it should not break. Yay. And again, we can see that we're within range, so it's not going to move. For this, you can see that we're getting a bit of spam happening here for the performing move to line of sight action because we haven't really changed that yet. And we can change this. The reason why this is being spammed is because the way we did our actions, right? Move to line of sight action is different than what we had previous, right? So that's what it's saying. Let's go back to this. And if I move my ship away again, so let's move my target way down here and down, right? Then it's going to start patrolling again. And I'm kind of behind this cloud, so it won't be able to find me until, well, until it sees me. And it's going to be performing a different action. It's going to say move to line of sight action because we've been detected. We're never going to go back to patrol action again because, well, we're performing the same action over and over again. So this is good. How do we kill the spam? Because this is the next piece that we need to do. Let's check this out and see if we're okay. Just going to switch it here. So the spam happens in the close combat enemy itself. The close combat enemy is slightly different from one thing to the other. The decision tree is the same. So here's our, let's go back to our decision. And here's our close combat enemy. So the close combat enemy, the decision tree is the exact same, right? So there's no difference. This is the .h, where the .h is here, the close enemy. Max speed is the same. All this stuff is the same. We're drawing the same thing. In the update function, we're calling the make decision method. And the make decision method is basically going to do what we've asked it to do. And at the bottom, we have some methods that we've defined, right? We have the patrol action. We have the move to player action, right? And those are the two actions that we've kind of defined, either move to player or patrol, right? That's what we have so far. And we have our build tree where we have a couple of additional things here, right? Because those are the only things we kind of set out in our build tree, right? So those are the two actions. We have a move to player. We have an attack node where we do a, kind of a attack action and so on. And those are the things we've kind of put together, right? That's the new attack action, okay? The patrol action, which is this one, is the one that's happening there. And just trying to see where that's happening. Set action state is into the move player and the patrol player as well. I wonder if this is different. Well, we did do this differently. And this is move to player action for the close combat enemy. To line of sight. To line of sight action. Just going to look at that. The line of sight node does a move to line of sight action. And move to line of sight action. Let's go to definition for this one. Go to definition. It's doing this, move to line of sight action. Line of sight action. And we're going to, let's look at this, go to declaration, go to definition. For this one, go to definition. We're going to be performing if it's true, yes, move to line of sight. And why is it spamming? Is it spamming? Move to line of sight. It's printing out that which is in the display. We're displaying that action every single time in the close combat enemy, which is in the, which is in the draw action, I'm guessing. Draw, events, sights, or attack. Yeah, I'm checking that out, Alex. Hold on a second. Draw, update, make decision. Yeah. And that's why it's spamming. So I guess we'll add that in the next time. Again, it's pretty good. It works exactly the way it's supposed to. And that's good. So now we can effectively switch between. Now the big changes are, again, I'm not going to go and try and go through this because I've got another class to go to now too. But what I want to talk about is a couple of things. So the big changes are when it comes to the range combat enemy, the close combat enemy does detection or just starting to move and getting our check range to line of sight is almost exactly the same as this. The difference is that we're setting health for this one. Let me just show you the health effects really quickly. Just going to comment this out and go back to the other way around for our play scene. So let's fix that back up, which is cool. I love the Klingon. The Klingon's pretty awesome anyway. But let's go back in here and put it back. So I'm just going to comment this part out and comment this part back in and comment this part back in because we need that anyway. And we'll comment this part out and we'll comment this part back in. And I think this will be everything we need to make things work. Distance check, ranged combat enemy. La 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 la. Yes, yes, and yes. Let's try that little other thing out, which Alex has given us, which is our damage. Yes, it doesn't. You're right, Al. You're right, Ethan. And so the great thing is that if I press the, if I move my target position way back, as an example, and I now move him down a little bit, he's kind of, the range is pretty tight. And if I press the F key, I get fire. If I press the D key, right? If I press the D key, let's show you that one too. Those things work as well for testing. So D, notice that my target is at 75%. Imagine if I got hit, right, by something. I can press the D key again, and it says perform a move to line of sight action. If I keep pressing the D key, it says now the target is performing the flee action. This would be running away, right? Okay, so we can set the target and the chaser against each other, which is pretty cool. If I press the R key, then I've been reset, and notice that I'm now performing the line of sight action, which is pretty cool. Excellent. All right, so that is the way we can test things out, and I think we're good to go for today. All right, any questions before we go? And this is your Lab 7 Part 3. I think I've covered everything, Alex. Yes, I think I have. And we will talk again next Tuesday. Please make sure. Is there anything you have to add to yourself? No, I think what we're going to do is I'm just going to bring up the lab report really quickly. And I think this is the lab report we're going to be using. We're in the process of putting this together, so it's not finalized yet, but we should be close to getting it done. Let's take a look quickly before I run away. So yeah, so Lab 7, it's pretty big, as you can see. We're adding version control 1% for this one. Notice that this one should equate to about 12% of your final grade. This is huge. So again, decision tree, filters, and file organization. We did that the last time. Action nodes and condition nodes, we've put those in place. The decision tree was created with a flaw. That is the decision tree without the close combat enemy. That's just the class itself. That's 2% of your final grade. Your close combat enemy and your ranged combat enemy are different and have been created, and they kind of work. And all the placing stuff that you've done, I think, yeah, this is pretty good in terms of everything that needs to be done. I think it's also pretty well balanced, where I would kind of put it as well, where the bulk of the code is in your decision tree and your 2 enemy subtypes, which are pretty good, of course, in the placing itself. So I think this is where it is. So please take a look, make sure that everything is working properly. I think this is pretty good in terms of what we're asking. Okay. So I think we don't need you to add anything else, because if I'm not wrong, and if I look at Alex's piece, it says a final note, we're leaving the actions for you for A4, but we will at least be able to demonstrate how the conditions change and different actions are being performed. And that's what we've done with this Lab 7. So I think you've got a good amount of, I guess, information and everything you need to get really moving on your A4. And if you haven't started A4, I highly urge you to do that. There's a lot to do and not a lot of time to do it. Okay, guys, that's it for me for today. I'll see the rest of you or everyone else next week. And next week, we're going to get right into tactical and strategic AI. We're also going to be doing more with our lab. Now, it said we're supposed to build the close combat action. A lot of this stuff, actually, if anything, we've kind of done here. So in the next iteration of the course, we're going to obviously update these things to show correctly. But for the most part, we've done a lot of this already. We're going to do more in Lab 8. Lab 8 is going to build on the things we did with Lab 7 and give you more information, more stuff to do for your Assignment 4. Also next week, one thing to note is that Assignment 5 will be released, which is your final presentation that you're going to be doing with you and your team for the game that you put together, for which is Assignment 4. Okay, so look out for that next week. That's it for me today, guys. Thanks so much. I'm going to stop recording on YouTube.